Hello, everybody. I'm Professor Figueira. I'm an Associate Professor of Computer Engineering and the Director of the Frugal Innovation Hub. And I'm here today to talk about humanitarian frugal innovation. Frugal innovation is the process of solving problems using less resources. Sometimes there is a misconception on that term. People tend to believe that this is about developing cheap solutions. However, it's not. The whole idea here is to be able to deliver the same functionality but with less resources. And that's what we're going to be, talking about today. And then there is humanitarian frugal innovation, which is basically a focus on the needs and context of consumers in impoverished communities. So here we go. We are supposed to come up with the same functionality of high-end products, but using less resources, and we want these products to make sense for impoverished areas, to solve their problems and pay attention to their needs. To do that, we have to change the engineering process a little bit. So the process is still the same. We're just going to add some factors to that. One of them is empathy, and the other one is a set of core competencies that actually form basically a set of guidelines when we are developing such solutions. Empathy is super important, and it's going to affect all phases of the engineering design process, as we can see. So the design process is still the same. It's just that we're going to have the empathy factor affecting all the phases. For example, when you define the problem, you need to really understand what the problem is. You need to understand how your target community lives so that you understand what makes sense for them. And then the same when you generate possible solutions. You actually have to make sure that the solutions are solving the right problem and are not creating other problems. Also, you need to do the same as we evaluate solutions and test a model. Every step of the way, you have to work with the target community to make sure that what you're doing makes sense. Some examples to illustrate. One of them is cooking fumes. It's a big problem in lots of different places. People live in tiny houses, they cook inside, and the fumes are really bad for you. They're really unhealthy. A lot of people have tried to come up with solutions for that, but to make or to come up with the right solution, you actually have to understand how people cook, what they like to cook, how the houses are, and things like that. Otherwise, you're going to end up with a solution that doesn't make sense for specific places. Also, you have to realize that the houses are small. You can have wires on the floor because that's dangerous. So all kinds of things need to be considered when you are designing, a new solution that will solve that problem. Also, another problem is that people don't usually have access to clean water, so they have to carry water. And they usually carry water in jugs. So when you want to solve that problem, you really need to understand, how this works. Where do people go? How do they like to carry these? How they like to carry these jugs, and so on. So understanding how they actually deal with that problem is super important for the design of a new jug, for example. Besides empathy, we need to talk about these guidelines, and they're super important when you're developing a solution. You need to pay attention to lots of different details to make sure that that actually is going to make sense and will fit into the place that you actually are targeting. So we're going to go around and talk about these set. The first one is rugged, and we're going to go around the circle. So solutions need to be rugged depending on where they are going to. They're going to have to take heat, humidity, cold, dust, falls, all these, and others actually. So you need to worry about that. If you come up with a solution that is very sensitive to dust, for example, it's not going to work in lots of different places. So you need to worry about that. An example of a rugged solution is tough stuff solar panels. They're extremely durable, they're water resistant, and can operate in low lighting levels. So that makes them really interesting for lots of different situations. Solutions need to be human-centric. They need to be designed based on a human need and to fit a human usage. You really need to worry about how people will use your solution. One example is a jerry can. It was developed by this organization called Nandes. So people used to go get water at these places with the green jug that you see on the left. And that is open, doesn't have a lid, and then basically the water wouldn't get clean to the destination. So they designed this new jug, which is big enough that you can carry, and it has a lid, so it basically fits the usage and the people who will carry them. Another one is simple. Solutions need to be simple so that it can be made and fixed locally, because this is super important. One example of simple is the Nazava filter. Basically, it's a water filter built with like a simple bucket, a couple of buckets. And it's simple enough that if it breaks, people will know how to fix in different locations. Nazava is actually located in Indonesia. Local. The solutions need to use local resources and be done at least partially by local people, so that again they can actually deal with things that break and maybe produce more of whatever solution you're proposing. One example of local is the Husky Power Systems. This is an organization that generates power from rice huskies. They are in northern India, and they realized that people eat a lot of rice, so there was a lot of rice huskies, and they decided that they could actually, generate power from that, and they do that in a community that has no access to the grid. They are able to provide a couple of hours of power after the sun goes down every night. Affordable. It needs to be inexpensive so that people can actually buy it. Otherwise, it's not useful. One example of that is the Jaipur foot. So these are inexpensive prosthetics, and these people came up with a material that actually makes sense for lots of different communities, and they generate this lightweight and durable prosthetic limb. So this has become really popular, in impoverished areas. Green need to be low power or help to provide power. And a lot of places don't have access to the grid, and if they do, sometimes they just have a couple of hours a day, if so. So power is a big deal here. And Weaker Solar actually is an organization that provides high energy solar systems to power medical lighting, mobile communication, and essential medical devices. And they came up with that because they noticed that people were dying when they got to hospitals, even though their problem was not complicated and could have solved it with a simple procedure, but the doctors couldn't do it because there was no power. So this basically is a system that comes into a suitcase like that, and they're very popular in places where you don't have access to the grid. Need to be lightweight because sometimes people have to carry it. So one example of that is World Health Partners. They are in India, in rural areas, and they have health workers that go around checking on people. So these health workers, they actually carry the diagnostic equipment in a backpack, just like the one you're seeing there. And if this equipment is actually heavy, this would be a problem. So lightweight is a big deal here. Needs to be adaptable, because sometimes a solution that makes sense in a place, it still makes sense in another place, but it's gonna have to change a little bit to adapt to the resources available. One example is Okabi. So this is an organization that provides an Uber-style SMS-based system. So Uber works really well here. And it's a good idea for other places as well, where people have a hard time getting in touch with transportation. However, in this place, sometimes people don't have access to smartphones and an app and GPS. So the service is still a good idea, but it needs to adapt to use the local resource like SMS, and maybe a voice module so that people who cannot read or write can actually access that as well. So different things need to be added to adapt the system to a place like rural Uganda. Last mile distribution. It may be necessary to go door to door advertising and selling, because there's no other way of advertising in TV or social media, for example. So you need to tell people, that you have something that's good for them. One example is the Solar Sisters. They basically have an organization that go door to door selling solar lamps. It's a good thing because empowered lots of women who actually work for them, and also help people who can use the solar lamps that they sell. And the last one is mobile. Everyone has a cellular phone these days, and they become a local resource. So you can actually use that fact to enable people to receive information and services that they couldn't have otherwise. And one example of that is World Reader. They have digitized lots of books in Africa and they make them available for people to create libraries in different areas and also for kids who have access to a phone with SMS to basically read for free. So if you don't have access to a real library or a book for that matter, you still, you're able to read and even learn how to read because these books are going to be available through SMS to your phone. Like World Reader, several other organizations are using the fact that people have mobile phones to provide services that these people couldn't have before. So this is the set of competencies that you're gonna have to consider when you are actually solving a real world problem in week 4. So you guys are gonna be presented with a community that has a problem and you're gonna use the design thinking process to come up with a solution for that by empathy and by following these core guidelines. So we'll see you next week. This is us. I'm Professor Figueira in the left, and this is Alan Baez, and he's gonna be running your lab. So see you there.